Hello everyone. In this video, we're going to talk about the POS that is part of speech tagging. So POS is a way to describe the grammatical function of a word. In NLP, POS is an essential building block of language models and interpreting tests. While POS tags are used in high-level functions of NLP, it's important to understand on their own, and it's possible to leverage them for useful purposes in your text analysis. So basically there are 8, sometimes 9 different parts of speech in English that are commonly defined. So let me paste each and every one of them. So as you can see, here are the 8 and mostly 9 different POS tags. So first is noun. So a noun is like suitable for anyone who has a name or is a person or place or thing or an idea. A pronoun is a word used in place of a noun, a verb for expressing an action, adjective which modifies or describes a noun, adverb, an adverb like we all know modifies or describes a verb, an adjective or another adverb. Preposition is a word which placed before a noun, conjunction which joins words, phrases or clauses, interjection to express emotion, and one is determiner or article which is a grammatical marker of definiteness or indefiniteness. There are many. They are not always considered POS but are often included in POS tagging libraries. So let's start with some basic simple example of POS taggings with 3 common Python libraries. We will be using NLTK, TextBlock and Spacy because I think these 3 libraries will be efficient to make your work done. So we'll do the absolute basics for each and compare the results. So let's start by first importing NLTK, and from TextBlock we will import TextBlock and pattern tagger, and we'll also import Spacy. So as you can see, I have imported all the libraries. So for our examples, we will use 2 sentences with the common word book, which can be a noun or a verb, to test how well the POS taggers work in a context. So we will be using 2 sentences. One will be please book my flights to California, and another sentence will be I read a very good book. So we will be making use of these 2 common examples, So let's start with the most common library for NLP in Python, which is NLTK. So what we will do is, so in this we just created a tokenized sentence, please book my flight to California, and we have used NLTK.pos_tag in order to get the tag for each respective word, and for each word we have printed. So as you can see, the please has been shown with the NNP, book with the NN, my with the PRAPS, flights with NN, to is shown with the capital TO, California with the NNP. Now let's use the same library for another sentence. For another sentence, I read a very good book. Here you can see I PRP, read VPP, a determiner, very RB, good JJ, book NN, which is noun. So what we notice here is that for the most part, NLTK properly recognizes the word in context. However, few errors such as please is tagged as a proper noun, which is NNP, and book is tagged as a noun, NN, in our first sentence when it should be a verb, because please book me a flight is where book is basically an action which has to be performed, which is a verb, but it has miscorrectly recognized as a noun, a noun. Now we will try with another library, which is TextBlocks. So let's try another library called TextBlock, which provides a simple API for diving into the standard natural language processing tasks. It's a very good Pythonic implementation of an NLP library and simplifies some of the common NLP tasks. Much of what TextBlocks does is a wrap NLTK and other popular NLP libraries to make them easier to use. Basically what it is doing is, so again for blob we will do, now you can see when I run this piece of text like please book my flight to California, by using the blob library, TextBlock library, I get the output as please has been given as the verb, book has been noun, my as a preposition, flight noun, to, and California NNP. So now let's copy for another example, which is for I read a very good book, and let's see what result it gets. Now when I run it for I read a very good book, here is the output. I has been PRP, read as in VB, as a determiner, V very as an RP, good as a JJ, book as a noun. So one thing to note here is notice the use of pattern tagger in the initialization of the block. The default is to use the NLTK tagger, yielding the same result as the above. This allows us to try a different POS tagger and check its performance. We can see that text blocks correctly identifies please as a verb this time, but still misses book as a verb in the first sentence. So now let's move on to one of the our favorite library, which is Spacy. And Spacy is the modern library in the advanced version of among these three, and it's incredibly robust for tons of NLP tasks and allows for customization if more power is needed. And this, again, as I have mentioned 100 times, this is currently my favorite NLP library, and let's check it out with this library. So when I do it for please book my flight to California, I get as please an int j, book as a verb, my as a pronoun, flight as a noun, to as an ADP, and California as proper noun. Now for second example, that is I read a very good book. So you can see the example and you can see the output. So we can clearly see that Spacy correctly tagged all of the words and it identified please like an interjection as opposed to a verb, which is more accurate, and also identified book as a verb in the first sentence. So as you can see, Spacy is so powerful and so accurate. So each of these libraries has its pros and cons. I believe you should start with NLTK to understand how it works, especially since it has so much robust support of different corpora. TextBlob is great when you want simplicity across several NLP tasks, and Spacy when you want one of the most robust NLP libraries around. So this was about the POS taggings. Now let's move on to the next topic, which is visualizing the POS tags. So we can do the visualization work on Spacy library through the display class. So we will import Spacy and download the English language, and we will also create our text as NLP object. Then we will import the display class from Spacy as follows. So you can see here I have imported Spacy and NLP Spacy.load at the loading of the English class, and I've passed a sentence, which is with most COVID-19 vaccine, you will need 2 shots in order for them to work. So to visualize my POS, we have to render the dependency parse through the style attribute. The render method from display C can work on Jupyter by setting the parameter Jupyter equals to true as follows. So you can see I have passed in the true, Jupyter value as true. Now by setting the style on DEP, which is dependency parse, the relation between words can be shown for the about text, which is like with most COVID-19 vaccines. So, and the syntax structure as follows. So when I run this piece of code, you can see the output like prep, prop, amount, most, and you can see the relationship. Okay, this figure is like quite big. So here I was only able to take a picture of to display on part of my text visualization. To see the whole visualization, we have the parameter option on the render method. So by setting the distance between words on options equal to 80%, for example, we can collect the whole visualization on the screenshot as follows. Now you can see I have passed the 80. Now when I run it, so you can see the picture clearer. So as we can see from the above visualization, the part of speech tags are defined for each word, and the relation, which is the dependency, is also shown in the visualization. The relationship can be shown through the curves as here, or through the lines as I will show later. For the lines I will show later. The word need is recognized, as you can see, the word need is recognized as the most important word in the sentence. Therefore, the arrows were emitted from it toward other word on its right and on its left direction. So the word need is recognized as the verb, and the word will has a dependency of auxiliary verb aux to it. But the dependency between you and need is NSUBJ, meaning nominal subject. So there is DOBJ, dependency between the verb need and the noun shots, which means that the word shots is a direct object, DOBJ, for the verb need. while the word to has a dependency of NUMMOD, which means numeric modifier to the word shots, and the word most and the word COVID-19 have a dependency of AOMD with the word vaccines, which means that both words are an adjective modifiers to the word vaccines. So now you can even see the dependency parse can show in the course POS tags for each token. So for that we have to run this piece of token. So like for token in doc, you have to print doc text in and you have to print like shown. So as it's shown. So this is where you can learn more about the dependency between words through the attribute.explain token tip, where we can see the definition of each dependency tags. So this output will be very helpful. So I would want you to just pause the video here and just make go through the relationship between different words and how it has been presented. So now previously we used the modifier options on our visualization rendering to change the distance between tokens. In addition to playing with the distance option, Spacy has other options such as color of the text, the color of the background, and whether it is a curve shape or compacted to a flat shape, the font of text, and more. We have to define each option inside a dictionary. For example, I can define a distance between tokens to be 90 and make a compact visualization by setting the compact value to a string of true. The text color and the background BG can take any string of color or string of hex code. The font can be defined according to a certain fonts that are available for Spacy, such as Time New Roman, that is defined as timed as follows. So you can see the piece of code. And this is the graph generated here. Now it has been with the straight lines. So as you can see here, I defined the options modifier as dictionary in the visualization rendering. The plot is compacted to flat. The font color and the background is changed according to my definition that is different from the default. As you can see here. So this is how we visualize the POS tags. I hope you like the video. Thank you.